So thank you, everybody, for staying until the end. And of course, we saved the best for last, right? and it was a good segue when people were starting attacking NLP algorithms and their bias. So we know as we deploy AI, we really need to be able to tackle what to do with AI's bias and the dangers that can happen because we know they're fragile and they can have unintended consequences. And we need to really tackle this next frontier of AI, which is to responsibly deploy AI and make AI trustworthy. So building AI systems that are trustworthy and that stakeholders can interact with will rely on, in meaningful ways, requirements to incorporating values into the design, development, and deployment of these systems. In this panel, we bring together experts on fairness, interpretability, privacy, transparency, and accountability to talk about how to put these values into practice and discuss where we are and where we need to be on the path towards achieving trustworthy AI. So with that, I'd like to introduce our panelists. So first of all, I would like to introduce my co-moderator, John Bassel, who is an associate professor in philosophy with an expertise in moral philosophy and AI ethics. And I'm glad to have him here join for this panel. And then I'd like to introduce our first speaker, our distinguished speakers in the panel. So first, I'd like to introduce Cynthia Rudin, who's there on the screen. And Cynthia Rudin is a professor of computer science, electrical and computer engineering, statistical science, and biostats and bioinformatics at Duke University. And her expertise is in machine learning and interpretability. And she's a recipient of the 2022 Squirrel AI Award for AI and for the benefit of humanity from the AAAI, which is the Association for the Advancement of Artificial Intelligence. And this is like the Nobel Prize and Turing Award counterpart of AI. Okay. And she's done a lot of work in translating AI to real-world applications, and she's also named as one of the top 40 under 40 by Poets and Quants in 2015, and other amazing things, and is featured in several news outlets in New York Times, Washington Post, and so on. So I'm very happy to have her join here in this discussion for Trustworthy AI. John?
Hi, everyone. I'm going to introduce first Tina Eliassi-Rad, who is a professor in computer science here at Northeastern University, in addition to being a member of the Institute for Experiential AI. She's also a core member of the Data Science Institute. She has a million publications. That's not accurate, but she's a very accomplished computer scientist. She works mostly in data science, or in data mining and machine learning, and her work spans a lot of different areas. I've had the pleasure, and she's had the displeasure of working together many times, and I know mostly her work on algorithmic fairness, where I always find her insights to be extremely valuable. And I'm also pleased to introduce Helen Nissenbaum, who's a professor in information sciences at Cornell Tech, and the director of their Digital Life Initiative. Helen is one of my favorite, she's a philosopher, one of my favorite philosophers of technology. Here, I'll just say this. Whenever I have students that come to me about a research project and I'm trying to explain to them how they go search for ethics of technology through databases, I first say, before you do any of that, just go see if Helen has written anything on it. It's going to be the best thing you read. Then you can go look through those databases if she hasn't. So thanks so much for joining us, Tina and Helen.
And finally, our last distinguished panelist is Crystal Wilson. He's an associate professor at the Curry College of Computer Science, and he's also a core member of the Experiential AI Institute and also founding member of the Cybersecurity and Privacy Institute at Northeastern. And he has worked in this area and at the intersection of big data, security, and privacy. And he has been a big proponent of accountability in AI and algorithmic accountability. He is the inaugural co-general chair of the ACM Conference on Fairness, Accountability, and Transparency. And I'm so happy to have him here to help us figure out how to make AI trustworthy. So with that, I would start the panel with a question. Can you say a bit about what is trustworthy AI? Why do you think this idea of making AI trustworthy is important? What is your work, and how do you see yourself contributing to it? Who wants to start? Maybe the order we introduce you. So maybe Cynthia can start.
Sure. So I work in interpretable machine learning, which is trying to design machine learning models that people can understand. And in terms of trustworthiness, I think that the major issue that at least I face is that data are not trustworthy. So what makes us think that models that we built from that untrustworthy data can be trustworthy? Like, you can't. And so that's why we need interpretability. That's why we need models that people can understand, so that they can look at those models and decide whether or not they're willing to trust them. Because if they're seeing something clearly obviously wrong with the model, then they shouldn't use it. I also think that predictive models, I don't think they can be trustworthy or fair if they're built from data, which is inherently untrustworthy, and we don't know what they're doing, right? So I think a key criteria for fairness, I don't think you can even really talk about whether a model's fair unless it's actually interpretable. So that's kind of where I'm coming from.
Tina?
Yeah. So let's start with AI first. So what is AI? I keep hearing the AI. I would like to meet the AI. I've been studying AI for a long time, but the AI guy. So AI is a scientific discipline, obviously. It's about building computer systems that think and act like humans, or think and act rationally. Alas, humans are not rational. So, and we've made a lot of advances in thinking and acting rationally. By rationally, I mean some utility function that we're very good at maximizing. Usually has a direct link to profits. And I have nothing against profits. The problem is that people can get hurt with some of the advances that are out there, because you can take advantage of them. So trustworthy AI, to me, is human-centered AI. And I gave you the definition of AI. And the reason it's important is because we live in societies that are infused with algorithms. We had a Nature piece, July of 2021, about how we live in algorithmically infused societies. Based on the recommendations you get, you go on dates. That changes the dynamics of our society. Then that affects the recommendation system. So your algorithms, this AI system, the AI is not an island. It lives within a context, which is society. It has feedback. It has non-equilibrium. It's a complex system. So I'm a core faculty of the Network Science Institute, and that's what we study. And for those of you who don't know, complex systems won the Nobel Physics Prize this last year. We're living in complex systems. Our algorithms are being placed in these complex systems, and we do not know how they affect, especially some of the folks who are marginalized. We know that it affects them poorly. It's just whether we care about it or not. And if I may, I did my first qualitative study recently. I went through with my team and looked at all the NeurIPS impact statements and all the NeurIPS reviews. So NeurIPS is this big conference that all of the AI people want to publish in. It gets over 9,000 papers per year, et cetera, et cetera. And basically, what these AI researchers think about societal impact can be broken down into three things. One, lack of agency. The algorithm is great. People who use it poorly. Two, denying responsibility. Whatever harm it may cause, it's not really anything. The good is much better than the harm. No mention of mitigation. It's your algorithm. You should be able to have some mitigation for it. And the last one is just reassigning responsibility to others, to the practitioners, to blah, blah, blah. And it was very eye-opening reading what these AI scientists think about fairness and negative societal impact. Basically, there was one which was like, yeah, my model is going to burn down the planet, but it's such a cool model. The other one was, oh yeah, this is going to cause harm to underrepresented people, but again, look at the math. How cool is the math, right? And that's where we are. So when we talk about trustworthy AI and why is it important, we need to first look at ourselves and see where our community is, and why is our community so screwed up? Where the person is like, yes, the planet is going to burn, but look at the model. And I'll stop there.
Thank you. Helen?
I don't know if I can top that. So I'll do what philosophers often will do, which is like just try and see if I can shape the question to understand it myself. So I'm going to assume that by AI we mean data-driven algorithmic systems of decision-making and control. And I don't know if that's too small of a subset, but I understand that this is more or less what we're talking about. And the part that I'm unsure of about the project as a whole in this panel specifically is we could be talking about AI as an approach to solving certain kinds of problems, that is to say, data-driven machine learning, algorithmic decision and control systems. Or we could think about the systems in which we've embedded some kind of AI mechanisms internal to that, generally speaking. Or we could think about AI systems that, the latter, but operating in the wild in a specific context. And when we talk about trustworthy AI, I actually think that question about trustworthiness of AI could be asked of AI in all of these different understandings, like specific systems, a general approach to solving systems computationally, and so on. So when I think, and I'm provoked by this panel to think back actually on some ancient work, and John, that was a really nice introduction. Thank you very much. I feel myself that I've written on, dotted around many different topics, and I'm so pleased that people will sometimes remember those ancient. I say ancient for papers that may have been written, 20 years ago. But one of them was on trust and whether you could model trust with security. And in the end, I found a lot of wisdom in the philosophical literature that was trying to define trust and adapt these definitions to, in those days, it was, computer systems and networks and so forth. And the thing that struck me about trust is that when you trust something, you have faith, you're vulnerable to a particular actor, and you have faith that that actor, even though they have the ability to harm you, is not going to harm you. And so when we say that a system is trustworthy, what we mean is we are vulnerable to these systems, and we have placed our faith in the fact that these systems are not going to harm us. And when you think about some of the markers of trust, and this really I drew a lot from the philosophical literature, you think about things, how do we know that this party is not going to harm us? Number one, we have a history of operating with these actors. They have a reputation that they've earned of not being evil, of not being stupid, of not being careless. They have certain personal characteristics. And now I'm thinking about all the companies that dominate. They have relationships with us in that the pilot isn't probably going to crash. Most pilots will not crash the plane, not only for our sakes, but for his or her own sake. there's a kind of mutuality and reciprocity. And unfortunately, in the case, and maybe the comments previously, and I'm just blanking on your name, I'm really sorry, is that a lot of the cases where people are subject to AI systems, AI decision making, we actually have different interests from the parties who are operating and developing these systems. Finally, we will often trust people because of role fulfillment. We know, a physician is very unlikely to do such and such because we understand the professional role in society. And so my concern about many of these actors who are actually developing the systems, these AI systems, and using them all over the show, is that these factors that enable trustworthiness or make trust a reasonable way to think about these systems are simply not in place. And by the way, I completely agree with the previous two speakers, particularly in Cynthia's effort to open things up and make these systems accountable and interpretable by the people, us, who are being affected by them.
Thank you. Krista?
Yeah, so I come from a cybersecurity background, which means I am not a trusting individual by nature. And it bothers me that we live in an algorithmically infused society and we don't know how those systems work. There's a fundamental asymmetry there. They're collecting a lot of data about us. They have a lot of power over us, the things that we see online, the prices that we pay, whether you get a date, whether you get a job, whether you get a house, whether you get government benefits, whether you go to jail or are set free. We don't know how those things work, and yet they increasingly govern our life. So that is why I consider myself to be an algorithm auditor. That's a fancy way of saying that I like to take apart people's systems, often without their knowledge or consent, to try and figure out how they work. Right? What is the data that's being collected? What are the decisions that are being made by that system? How does it impact individuals? And ultimately, now that we have this transparency, how do we feel about that? Right? Are there problems we can identify? Is there change that we want to affect through this transparency? So it concerns me that this lack of transparency leads to a lack of accountability. The physician that you would trust to make a clinical decision, they're not the one who developed the model that's diagnosing the disease. That's some third party that's removed from the context, and they're shielded by that relative anonymity. So how do you create accountability? So, I think auditing is really critical in this space. If you look at cybersecurity, we don't trust that systems are built well from the outset, right? It's standard practice to have people come and do adversarial assessments to try and figure out, was something built the way you think it was built? Is it vulnerable? Right? I think we just have to have the same kind of assumptions with AI and machine learning systems. The issue is not that there's a bunch of racist engineers building things that are intentionally evil. It's that there is negligence, right? Data is unpredictable and typically biased, right? People choose objectives for systems that are not well aligned with values. So there should be this kind of oversight. People need to go in and look at these systems and try to figure out, are they actually matching the values that we claim to espouse? Are they working the way that we think they should? Even in the absence of malice, right? Things can go horribly, horribly wrong. So we have a long way to go in this regard, I think. There are some people like me who try to probe these things from the outside, treat them as black boxes. We're nowhere near the point of like cybersecurity where it's relatively common to have a company bring in people to do assessment. That's extremely rare for these kinds of algorithmic issues. Getting an independent party to look at something with consent. But one of the things we're doing in the Experiential AI Institute is try to develop those methods and hopefully get people comfortable with the idea that their systems are going to be audited. They have to be audited if you want to build things that are trustworthy.
Thanks, Christo. Thanks, everyone, for your answers. So we're going to transition to, so a lot of that was about, trustworthy AI is about values, whether we're thinking about embedding systems, embedding an AI system in a socio-technical system, thinking about how do we enable the trustworthiness of that system or the trustworthiness of the AI system itself. It's really about building values into those things. And it's no coincidence that you all represent sort of different values in this space. We have fairness, we have accountability, we have a transparency, and we have privacy. Of course, you all do other things that are value related. I wonder if we could talk a little bit, and this, Krista touched on this a little bit, about what are the obstacles of translating the insights you identify in your work into actual systems that get uptake and get used by practitioners and ultimately in communities to build those values into AI systems. And we can start with, we'll go almost backwards. We'll go Helen, Tina, Cynthia, Christo. Helen, you're on mute. Yeah, you got.
No, I was muted. I thought I'd never do that again. Okay, so there's a variety of different bits of work that I do that are relevant. And I won't talk so much about the work on accountability and transparency, because it sounds to me that we have, better experts who can discuss it. But I think it's hugely important, and I think that we're losing this battle. So one of the areas that one of my postdocs has been looking at, Meg Young, is to think about the uptake of these systems in urban environments, where cities and maybe many other actors are purchasing these systems for use in very mundane things like traffic control, congestion control, and allocating kids to public schools and decisions. I mean, that's not so mundane, but decisions like that. And the cities purchase these systems and they're not given access to the systems because they're trade secrets, and this would be problematic. So this is huge, and I hope that your project is going to really push on this issue. From the work that I've been doing, perhaps the most is privacy, and privacy is contextual integrity, where we think about data flow being norm governed, and these are norms that govern data flows expressed in terms of 5 parameters. I won't go into the whole theory itself, but the practice of machine learning or data-driven algorithmic systems involves just mushing a bundle of data together and extracting models with no consideration for the societal data flow norms that are being just overridden as a result of these data practices in order to extract knowledge from the data. So that's an important problem. I would love to discuss the challenge, but the second challenge within the theory of contextual integrity is to say that when you have practices that obviously are violating entrenched expectations, we need to justify these new practices in terms of values, societal values, and contextual values. Like for healthcare, we need to be promoting health and population health, individual health, and so forth. But so far, the parties that are creating the algorithms and the models and so forth are not necessarily held to account for utilizing these systems to promote the purposes and values that are important for society. So I think privacy is massive. There's a lot more I can say, but I'll just pause now.
Thanks, Helen. Tina?
Yeah, so there's no accountability for me as an AI scientist. I could do anything I want. Absolutely, and there's no professional norms, so I cannot be excommunicated from the society that I belong to. Perfect, right? Like in any other discipline, if you do certain things, you may get excommunicated, right? Like the doctor in China that was using CRISPR to change the gene of a fetus, right? And he's in jail, I believe, now, and he got excommunicated. There's nothing technically, that you can do within AI that will get you excommunicated from the community. So there's no accountability. And in fact, this is part of why we were looking at the NeurIPS impact statements. They're like, yeah, this is going to harm people. It's future work. It's not clear who's going to do this future work, but it's future work. And in the meantime, look at my math. So there's no accountability. So this notion of societal values, I think this is where, like, being a professor and being an educator, it's like, in a sense, I've given up on the older folks. It's just about training the young people. So this morning, I wasn't able to be here because I was on a panel on Museum of Science here, where we were having high school kids from 65 different countries, thousands of them, asking about how do we navigate our AI society, our algorithmically infused societies. And so I feel like the thing to do is, if we want to change societal values, we have to start younger. Because at this point, I mean, these AI researchers are going to public square, basically, and saying, it's okay, it's causing harm. Look at the math. And somebody down the road will fix it, which is just really depressing. So I'll pass it on to whoever's next.
We'll go to Cynthia next.
Wow, that is so depressing. Oh my gosh. But the one redeeming thing I can tell you is that I don't believe NeurIPS actually represents AI. I was recently doing some statistics on words, keywords on the NeurIPS accepted papers titles list. And, you know, I looked up things like radiology, where, you know, AI is revolutionizing radiology, but you would never guess that from the NeurIPS titles, right? So I think NeurIPS is one of those things that maybe should go by the wayside because it doesn't represent AI. Anyway.
Fighting
so
words,
you asked what were
Cynthia.
the-
Fighting words. Those are fighting words.
They certainly are. They certainly are. But I have every right to sort of say that, given how many times they've rejected my papers for being
Of course.
pertaining to the real world. And I want to bring up the notion of human-computer interfaces, because we know how to build AI systems, but we don't know how to make them interact with humans. And this is really a serious problem. I don't know how else to say that. You know, if you're a doctor trying to build an AI system, how are you going to do that? How do you know you can trust it? How do you know that that model that got spit out from the data is the right model? And so I think all these, like, human interaction questions are super critical. And then not just like human-computer interfaces, like human has to pick the model, not just that, but even just communicating with domain experts. So even if you have an AI human in the loop, talking with the domain expert and trying to help design that model, it's still a difficult problem, because you have to make sure that the data are okay. You have to make sure that, you know, the model that you're producing is aligned with the domain expert's interests and values. And so all of that human interaction stuff is complicated. So in terms of, okay, so I want to get back to the topic of auditing AI systems. So we were looking at the COMPAS score, which is a very famous, it's not exactly AI, it's kind of traditional statistics, but it's a proprietary algorithm that is used throughout the justice system to determine whether someone should be given parole. And ProPublica claimed that it was racially biased, and they wrote this whole article that just made huge waves and made everybody want to work on algorithmic fairness. But the thing is, ProPublica forgot about transparency, and it turns out that the math in their article was just purely wrong. What they did was they approximated the nonlinear COMPAS score by a linear model, and then because the linear model depended on race, they claimed that the black box depended on race, and that actually is just mathematically incorrect. And so we went back and wrote a paper saying, look, their math is wrong, but they completely missed this other problem, which is that people, when they use the COMPAS score, there's a lot of typos that get made in the inputs to those scores. And then what happens is that people get denied parole based on typos, and people get, go free based on typos. And this is like a major noise factor added to the justice system that doesn't need to be there. And it's because of lack of, the understanding of the way that humans work with algorithms. So I think that's fine. I have a whole list of topics that I could go, but I think that sort of covers the most important one.
Thanks, Cynthia. Krista?
So I'll say two things. One, sort of riffing off Tina, I think we have an educational pipeline problem. We're very good at training engineers. We're not very good at training engineers who can also speak the language and recognize when values are at play in their work, it's somewhat unsurprising to me that we end up with systems that are just negligent and naive. We're not training a lot of people who are equipped to do that work in the right way. And we're not doing a good enough job of building bridges to other disciplines who do speak those languages and integrating them with engineering. So the other big thing that I think is a huge problem is access. The law stands in the way often of getting access to systems and trying to audit them. You're likely to get sued. Until recently, you might have been a federal criminal for doing this work. That has improved, but that took a fair amount of fighting to get to that point. But even beyond that, how do you get access to some proprietary systems, say, that are being used in a courtroom, or the systems that are being used for credit scoring? I would love to audit those systems, but doing so would require me to commit fraud. There's no requirement for anyone to get double-checked for any of this. There's no requirement that if you do get audited, the results are public or transparent in any way. So until we can touch those systems, and there's a mandate to do so, because companies are not going to do this willingly, we're sort of stuck.
I mean, I am completely on board with this issue of transparency, the right to contest, the interpretability, that whole family of issues. And I'm wondering whether you think this is a societal policy issue that we need to force companies to provide some sort of insight into how their systems work, and maybe that can help us capture some of the stupid ways in which these systems are error-prone. Or do you think it's a technical matter that the people who are writing or the machine learning algorithms, or whatever the pipeline is to go from a bunch of data to the upshot, it's not being done in a way that makes it possible for either insiders or outsiders to gain insight? And I know that there's a lot of voodoo stuff surrounding things like deep learning and neural nets, but I'm wondering where we could operate to bring exposure to what's going on. Society, policy, or technology?
You want to take that first?
But I think that for any decision that deeply affects human lives, like loan decisions, parole decisions, those sorts of things, I think that we should have a law that says that the model has to be interpretable unless you can prove that no interpretable model exists for that problem. And since I've worked in interpretable machine learning for so many years, I know that there's always an interpretable model that you can construct. So basically, it would just force all these companies out of business and have people, create models that were actually inherently interpretable to use in parole decisions and so on and so forth. So that's my view of it. There is also a computational problem, as I mentioned. You've got to, if you want something interpretable, you have to optimize for interpretability, right? You can't just optimize for accuracy and hope that it's going to be interpretable. You actually have to optimize for interpretability too, and that's a computational hardness problem. But we got that one. That one I think we can handle. Okay, Christo, I'm going to pass it back to you.
Yeah, I mean, so my position is that transparency is necessary but not sufficient. If a system wasn't designed with things like interpretability or fairness, considerations of ethics and values from the beginning, you've basically already failed. You know how that audit's going to go. It's going to find a bunch of problems. And the audit, of course, is post hoc, right? The system's already out there causing harm, which is itself hugely problematic. We did a cooperative audit with a company. They asked us to come and look at their system. And one of the only reasons I agreed to do that is because the company had already said, we designed our system to be fair in certain ways, and we want you to test and make sure that it's behaving according to the things that we have said, right? We've chosen a fairness baseline. And I think that facilitated the audit, right? They'd already done a lot of the hard work. We're just double checking it. If a company came to me and said, hey, audit this thing, and they had done no prior work, right? They haven't thought about fairness. They hadn't thought about interpretability. They were just hoping that it would work out. I wouldn't even do the audit. Because what's my baseline for assessment at that point, right? You just have this thing, we know it's going to fail somehow in some way, right? You haven't built this for success. So I mean, I totally agree that success in terms of building something that's trustworthy starts at the point of conception.
If I may riff off on that. So a lot of people say, oh yeah, we just need laws or policies, et cetera. And I think that that's fine, you could do that. But we need a multi-pronged solution to this. And so as I was saying, education is a piece of it. The laws are a piece of it. But we know with laws, they're very slow to pass. So in the meantime, people are being harmed. What are you going to do about that? And in fact, in this whole space, I feel like there's a chasm between the privileged people who are publishing lots of papers and saying, look, we're advancing science, and the people who are oftentimes from the marginalized community who are saying, your systems are causing harm. Do you care? And basically, they're like, no, we do not care, right? And so, yes, you could put in laws, but good luck getting that going until so basically this generation is going to die, right? In the meantime, they're gonna suffer harm, and there's no accountability. So we really need professional norms within AI. We need to police ourselves. Other disciplines do it. We just don't like doing it. I guess we don't like regulation.
Can I ask a question to Tina and to Cynthia? Because Tina raised this and Cynthia also followed on about what's your advice on what can we, I mean, we're in the ML and AI community and also can influence how, let's say, Europe's reviews are made or ICML or KDD. What's your advice that what should we do to help solve this problem?
And Tina, you can't say burn it down.
Burn it down. Fine. Know me too well. I think education, right? So part of why we went through all the NeurIPS societal impact statements and all the NeurIPS reviews were to see where the community is. And, you know, there are people who specialize in like survey methodology and how do you design surveys to also educate people, right? So our goal wasn't just to see how bad we are, but just to see really like how can we change the ethical reviews that are happening at NeurIPS, and how can we ask for the authors to provide impact so that they think about the ethical aspects up front as opposed to this ethics washing at the end that Krista was talking about. And then the other element, so I know you had Rahid Ghani on the first panel. I remember that Rahid was saying when he was running the data science for social good, the interns would go with the cops and with the ambulance drivers to actually see what happens in society. So if you really want to be experiential and you really care about trustworthiness, you send the PhD student with the cop out there, right? So the PhD student sees what's happening and how the algorithms are being used, right? The same way with an ambulance driver, et cetera, et cetera. So I think that's the way to win hearts and minds.
Thank you. And Cynthia?
It's an economic strategy, which is to allow applied papers to be published at these top venues, or at any top venues. So I wrote, I edited a special issue of machine learning called Machine Learning for Science and Society with Carrie Wagstaff back in 2013. And we basically wrote like the intro to the special issue was like, we have a lot of talented people, but they can't work on applied stuff because they can't publish it in NeurIPS, right? And that's the truth. And so, my goal since before that time, right, for the last 10 years has been to try to figure out how people can publish applied work. Because that's, imagine if NeurIPS all of a sudden switched from accepting only math papers to accepting only applied papers that actually help society. Then what would happen? First of all, we would solve a lot of society's problems. It would be amazing. And second of all the top brains in the country working on, not just in the country, in the world, working on AI would all of a sudden go, ooh, I think I want to go solve applied problems and go help the world. And right now they can't. They actually can't even do that because they can't get promoted because it's so hard to get an applied paper accepted. And so I've been trying to do everything I can to solve this problem for the last however many years. And I'm now on the board of SIG KDD, and so I'm going to be working with them to try to revise KDD's whole everything. I don't know if I'll be successful because I have tried before and not been successful to do things at other places. But I'm going to try, I'm going to try.
Thank you. John?
So thanks. I want to ask a question that's related to this, but also about interdisciplinarity and working across disciplinary boundaries. But so other fields have these robust ethics ecosystems where people, there's lots to criticize in those ethics ecosystems, but they're like much more nuanced criticisms. It's not that there's a lack of one. There are scholars that understand the language of ethics. They have codes of conduct. There are laws. There are incentives to orient people towards good outcomes. And that's largely lacking in the AI space. That's one of the things you said. So in those other fields, though, they weren't always like that. There were culminating events that caused that sort of coalescence around building such an ecosystem. At the same time, in the AI space, we see headlines that should do that every day, and it hasn't seemed to work yet. So I'm wondering, continuing the theme of like, how do we start to build that from where we are, but also part of the challenge is just being able to work across disciplinary boundaries. And so you're all incredibly interdisciplinary scholars. How do you do that? How do you bring people on board to these kinds of projects? What are the challenges? And how do we start building that kind of collaborative endeavor to make AI, to realize the promise of AI while avoiding more bad outcomes, not the worst of them. We're already too far gone, according to Tina. Maybe I'll start with Christo this time, if that's okay.
Sure. I think it starts with just a recognition that you're not building AI in a vacuum, right? Everything is inherently socio-technical, so if you're not being interdisciplinary, you've already failed. And this gets back to Cynthia's point that we need to pay a lot more attention to applied work that's deeply engaged with all the aspects of this, the human interface issues, the anthropological issues of where this data came from, and the socio-historical context of what, where is this being deployed. If you don't have those pieces, what you're doing is it's a toy. But if you do this, and you can do this, the work that you produce is so much more impactful. Right? It really reflects a real problem in the real world, and maybe you do some good, and not just saying you're doing good. Like, I have a new metric for fairness, and here's some math.
I see we talked to the same computer scientist. Cynthia?
So I've just said, so I completely agree, right? I completely agree, and I've just said my approach to this is to allow people to publish. Because frankly, if you have two assistant professors, one work in applied work and one work in theoretical work, who's going to get the most NIPS papers? NeurIPS papers, it's going to be the theoretical one. So to encourage people to do this much more difficult applied work, you have to allow them to publish it. Otherwise, you will continue to have the split of people, all the academics doing math, and you'll have the people who want to do applied work working for these companies that are trying to make a profit, and there's not that bridge because it's not that easy to find someone who can do that. I really think that's a major issue. Yeah, you have to incentivize it.
Helen?
Yeah. I wanted to, if you don't mind, I want to say something about education, applied work, and interdisciplinarity and they're all sort of linked to each other. I've bashed my head against the wall with the question of education and teaching, ethics to engineers and so forth. There's some versions of what's being done at the moment, which is, integrating ethical thinking within technical courses. And it may be that this is a promising approach. Christo mentioned the word values at play. And I don't know if it was specifically the model, but we have this model of values at play, which tries to expose technical students to ethical thinking within the process of doing work on technical topics, to show that these two ways of thinking, if you're a deep thinker, you can't really tear them apart. And the problem I'm confronting always is that whenever I suggest that, oh, we need a few more hours in the syllabus to actually have students take courses like this, I'm always told, oh, there's so much to learn in engineering and computer science. We just cannot give you enough units to do what you need to do. So I think it's like turtles all the way up or down, or it's firstly a recognition. We need a recognition that teaching people these skills is actually valuable for them being computer scientists or them being computer engineers or data scientists. And it's not just this like add-on thing. So that's my one comment. The other comment about a so-called applied work, I don't like that word, Cynthia. I think it really undercuts what you do, because it's really hard work to take some of this theoretical scientific knowledge and even showing how it's applicable in the real world. That bridging work is fundamental work in its own right. And I think, I don't know, in philosophy, we try to use the term practical ethics to not make it seem like we're just taking ethical theory and then just plugging it onto some applied question, because it really isn't that. So I think we need to elevate the nature of that work so that it's seen as fundamental research in its own right. And that gets me to the main question, which is about interdisciplinarity. Part of the issue being that it's actually quite hard for, say, a philosopher and a computer scientist to be motivated to work together, because there's sometimes easy questions for philosophers that are hard questions for computer scientists, and vice versa. The kind of issues that I might want to dwell on are not like researchy enough for the computer scientists to get their paper published in Europe. And so in my view, this is why there's a huge obsession with work on bias. I think bias and unfairness are very important societal questions, but they don't warrant the kind of domination that they've had in these AI machine learning conferences. And in part, the domination is due to the fact that there's a mathematical expression can be a mathematical expression of these problems. And this really excites the computer scientists and engineers, even though there are so many other ethical questions and harms that can befall us because of AI and AI systems. So I don't know how to solve the problem. I've had to bend quite a lot in order to, because I love the interdisciplinary, multidisciplinary work. And I haven't been disappointed, but still, it doesn't come easy.
Thanks, Tina.
So if I may, a couple of things. So one is that I feel like there's this us versus them. So whenever I go and talk to my people, I say, how many of you would like your algorithms to be used on you? Nobody raises their hand. Nobody. Not even the pale males, right? So nobody raises their hand. So there's this notion that I'm developing these algorithms that people find useful and make money off of, but that the algorithm will never be used on me, which is very weird. So I think like just changing that mindset would be good for the folks who are designing the algorithms, that yes, your algorithm may come back and bite you. And then second, obviously interdisciplinarity takes a lot of time and effort, right? It's a lot easier for me to talk to a computer scientist than talk to a philosopher. But it's very rewarding. I mean, I chased ethicists for 5 years to teach me ethics. I didn't learn a thing, and it's all their fault. Not my fault. Well, no, I know some things about ethics, but that you cannot say, oh, these are like ethical features, and I will like build a machine learning system based on these ethical features, right? It's more complex than something that you can quantify. And so you need to care about the context. And along this, I'm going to bring Rahid into it again. I remember one time he was telling me he went to a police department and the police chief was telling him, can you tell me if my department is racist? Well, how would you quantify that? right? And like, it still stuck with me. And this was, I think it was in Australia that Rehi told me this. And it's like, okay, how would I do this, right? And of course, I would approach it very differently than a social scientist would approach it, than a philosopher would approach it. And this is the rewards of working in interdisciplinary fields. You get to learn.
Thanks. Crystal?
Oh, I thought I started this one.
I think he already answered. So
Is that true? Okay.
Maybe,
I mean, I can rage more if you want.
maybe we should
Well, it'll be less than Tina's. Go ahead, Jenna.
let's have the audience ask questions for now before we run out of time. So, are there questions from the audience? Yes, Amanda.
Thank you so much. So forgive me if I missed this, and for some reason I feel a little discomfort asking this question, but I hear a lot about a lack of accountability. What I'm curious about, and how we need to educate, who do you think should be held accountable? I find that to be an important question. Should it be the company that is making the software, the data scientists? Who do you think should be held accountable? Because I don't think that there can be change until we actually see accountability in action.
Who wants to take that question?
The answer is it's not really clear who should be accountable for every domain. But so let's talk about medicine, right? So let's give an ethical question that some doctors brought to me and to some of my colleagues. And the question is, what do you do about products for in vitro fertilization? So there's all these like AI products for in vitro fertilization, and those select embryos. So they can select, nobody knows exactly how well they work because they haven't been tested. There's no like outer sample testing done on them. They just get advertised as being really helpful. So let's say that those models have a bias, like a gender bias. Okay, well that means that there's going to be more one of gender in the world. This is harmful, right? Or let's say that they select for a particular mutation that where the person will have a serious disability or something like that. So now, on the other hand, that takes the embryologist out of the loop if you just have the AI system like making the decisions. But what if instead, what if you keep the embryologist in the loop by making the algorithm transparent, right? Making it interpretable. And so the algorithm is telling the embryologist, they're saying, look, I'm selecting this one because it's a little bit bigger than the other one, or its measurement on this side is a little bit bigger than the other one. Then as long as the embryologist is actually in control of what's going on and they actually understand what's going on, then the embryologist can actually be accountable. And you can have this for lots of different like medical domains where, for instance, I work with neurologists, and these neurologists are dealing with critically ill patients. And we tell them exactly, like, you get 3 points, the patient gets 3 points for this, 3 points for this, 1 point for that. And that predicts their risk of having a seizure in the next 3 hours. And then the doctor can say, like, something, I don't trust this scoring system, or I do trust the scoring system. And because that thing is in the doctor's, complete control, then the doctor can stay accountable for their own patients. So it's kind of making it interpretable brings the accountability back to the human who's in the loop there. It goes very far beyond this. For instance, with self-driving cars, right? Let's say you have a self-driving car and the driver doesn't actually have any control over the vehicle. Then the question is, okay, well, who's responsible if that car crashes? And it's like, well, you need to be able to audit that algorithm that made the car crash, right? So you need to know, well, why did it crash? Is it because the algorithm thought that deer was actually a person, or did it crash because somebody put up a thing to confuse it, right? And then you can see the person who put up the thing to confuse the AI system. So so I think there's a lot of deep questions in there, but I think accountability and transparency kind of go hand in hand in a lot of ways.
Thanks. Krista,
Yeah, I also think it's a great question, and it could be asked in two different ways. One is to say who should be, and the other question is to say who is. But as if we can actually discover who is accountable. And often I think a little bit building on what Cynthia just said, we also ask, like, what is the goal that we want from attributing accountability? And we have different flavors of accountability, like responsibility, answerability, accountability, liability, where the goal of it is to compensate a victim, and that may be different from the party who is accountable. If we want to say who's the most likely to be able to change this thing. So it really, I mean, we can do all of the above, but sometimes we can also nominate an accountable party, and it could be, we can think, oh, the physician is the best positioned to be accountable in this case. Therefore, we need to make systems such that we can expect physicians to be accountable. If the army screws up, the Secretary of Defense may have to resign, even if that person wasn't causally involved in that mess at all. So sometimes in society, we decide to nominate. So there are lots of different ways to answer that question. And we haven't really made a lot of headway with this question. I mean, we're trying, but we haven't. And I think it's an important question for a project like yours at Northeastern to tackle.
Yeah, I agree with Helen. I mean, if we build systems that are very transparent and very well documented, then maybe it does make sense for the accountability to fall to the user, right? It's the employer who's misusing a screening model, the physician who's misusing a diagnostic model, right? They had the knowledge and tools available to them, and they're doing something wrong. But until we achieve that, I mean, I think accountability has to flow back to who built the system. Systems don't just spring into existence. They're not natural phenomenon. They don't come out of companies, right? They're built by people. So amongst the people who built the thing, they're ultimately, I think, the ones who should be accountable. Who among them is sort of a more challenging question. Is it the executive who decided to just let a development process go wild with no oversight, you know, didn't ask any hard questions about where data was coming from, right? That's negligence. Or is it, you know, individual data scientists who made bad decisions about, you know, data selection or objective choice and didn't apply best practices or tried to hide things, right? Maybe then ultimately they're responsible. But ultimately, I mean, I think people have to be responsible. That's how we achieve accountability in pretty much every other aspect of life. It's someone fears something. Otherwise, it's just a smokescreen.
I agree with Krista.
Thank you all so much. Please join me in thanking our panelists. Thank you all for joining us, and thank you all for staying to the session. I'll let Jen say a note about the transition that's about to happen.
Yeah, thank you very much. It was a lovely panel and very enriching discussion as well, and inspiring, and a lot of challenge to us working in AI. Well, Osama, would you like to say the last words for the event?
No, okay. No, thank you, everybody. Thanks for it's been a long day. I appreciate your participation and your patience, and your coming along with us on this journey. I hope that today gave you an idea of the wide range of things that we need to think about, and of the wide range of collaborations that we need to establish to make this endeavor a success. We do think AI as a tool and as a technology has a future in helping many disciplines and many fields. And we fundamentally believe that by actually looking, and I don't know whether Cynthia is still there or not, but in fishing for the most interesting problems, in getting the technology working in real solutions, where you have real constraints, real problems, real deadlines. This is how the rest of science happens, right? it's nonsense to say, you know, this is not an applied science. If you go into the core sciences, it's all about, I have a hypothesis, I test it, I see it, does it explain something or not? And we need to evolve towards that, and I think that's going to be one of the key ingredients to advancing AI in general.